When electronic cigarettes were introduced into the US market around 2007, they looked a lot like a combustible tobacco cigarette. They had a battery on one end that looked like the tobacco end of a cigarette, and they had a nicotine reservoir and a heating element called an atomizer in the end that looked a lot like a filter. These devices have a pressure transducer that when the user puffs on it, the negative pressure from their puff trips the atomizer. The atomizer then begins to heat up, evaporating the nicotine solution, or e-juice as it's commonly called now. The e-juice is literally evaporated or vaporized, but then when it moves outside the heated zone, it quickly cools and forms a condensation aerosol, also appropriately called a fog. The batteries of these devices were limited by their form factor. Because of this, users were oftentimes unsatisfied with their performance or with how long these devices would last throughout the day, oftentimes using multiple batteries during the day and not knowing whether their battery needed to be replaced or their nicotine reservoir, or maybe both. Other devices were still modeled after a combustible cigarette, but they're slightly larger in diameter, allowing for a higher capacity battery. Around 2009, the first second generation e-cigarette was introduced that looked a lot like this. It had a small battery that was considerably more storage capacity than these little batteries on the electronic cigarettes. This is around 200 milliampere hours. This is around 600 milliampere hours. This device resembles a pen much more than it does a cigarette. It's actuated by pressing the button instead of by the negative pressure from the user's puff. Pretty quickly though, these were replaced by larger batteries that were around 1100 milliampere hours, and even still by larger batteries that are around 1350 milliampere hours. Another innovation that came pretty quickly was the variable voltage function. This device has a voltage selection where the user can twist the barrel, which changes a rheostat on the bottom, which assigns a different voltage from the battery to the atomizer. With these second generation e-cigarettes, users now have a clear tank or a visible tank where they can see how much e-juice is left in their reservoir. They can visualize their atomizer wick, and they can change their atomizer to change the resistance on the coil. Lower resistance allows more electricity to flow through the system, which means the device uses more power. Changing the voltage also allows the user to change the amount of e-cigarette aerosol produced. Increasing the voltage increases the power as a squared function. With all the customizability that is now available in second generation and even third generation devices, users have many options to tune their device to their desired needs. One, they can select the concentration of the nicotine in their e-juice. They can select the resistance of the atomizer in their tank, and they can select the voltage of the battery, which is supplying electricity to the atomizer. This brings us to our research question: what is the effect of vaping power on e-cigarette aerosol?